Hey everybody, great to be here to talk to you today about high accuracy GNSS. My name is Eric Gackstetter from Discovery Management Group. Just by way of background, I've been in the sort of high accuracy GPS business for about 30 years now. Way back when high accuracy GPS was really expensive and really not that accurate compared to what we have today. I was a product manager back in the 90s creating GPS mapping systems, and back then, real-time corrections really didn't exist. It was post-processing was the only way to get down to quote-unquote high accuracy, and at that time high accuracy was sort of in that 2 to 5 meter range, and you had to collect data for tens of seconds or minutes and then go back and post-process, and sometimes there's headaches with post-processing. It wouldn't work. There's this whole overhead that you had to go through to get the results that you were looking for. And today it's so easy to just turn on a receiver and get centimeter positioning just in a few seconds. And so it's an amazing time. GNSS has really transformed over the last few years. And so with respect to my talk today, this is a great example of a project that's pulling together some really neat GNSS technology and some really neat Esri technology that we haven't seen implemented before. And in this particular case, it's applied to precision agriculture, but you could apply this to other types of industries across the board that have a requirement for high accuracy GNSS. And I really like to talk about this project because it encompasses everything from high speed, high accuracy data collection to data communications in a rural area that doesn't always have cell coverage. And so in a way, it's one of the most leading edge precision agriculture applications that we've seen. So the title of my presentation is Efficient Centimeter Level GPS Data Collection and Management on a Vineyard. And so the challenge when the Vineyard approached us was, hey, how do we create an efficient data collection and management system for 500,000 vines? And sort of the first question might beg is, why do you want to monitor or track each individual vine? Well, they're really interested in the highest quality product that they can produce, and so they're actually treat each vine as an asset and do quick inspection on each one periodically and annotate its condition. And various problems may exist. For example, if a vine is not producing, it might be due to irrigation or drainage or disease or something along those lines. In past years, they would use a paper-based form, and so if you can imagine walking between rows of grapevines and having a sort of a tally sheet that you mark walking down the vine rows, and then trying to compile that data and make sense of it. If it was 50 vines, you could sort of keep track of that in your mind. But with the 500,000 vines spread across many different blocks in a geographic area, that becomes a very laborious and difficult task. So the first task of this challenge is, okay, how do we identify each vine? So if I need to identify it somehow to apply some treatment, we need to give it a serial number or some other identifier so we can communicate effectively with the farm team on which vine we're talking about. And so there was really two methods of vine identification that were being considered. The first one was just attach a barcode, just like you would attach a barcode to a piece of clothing in a retail store. So you scan it when you go to the checkout counter. The same kind of thing here is you could create a barcode, an outdoor barcode for each vine and attach it to that vine. And so when you'd walk up to that vine, you would scan it, and that would bring up the record associated with that vine. But when you start looking at the costs associated with that, outdoor barcodes that can survive in that kind of environment cost about $1 a piece. And so obviously over 500,000 vines, that's $500,000 just to have the cost of the barcode itself. And that does not include the labor to install the barcodes, the barcode scanning equipment, the barcode software, management software, the whole workflow back into the system of record. And so we came up with another idea that how about we use centimeter accurate GPS location to identify each vine. So if we use survey grade GPS equipment, we can map a vine down to a couple of centimeter level. And we can do that actually fairly inexpensively compared to barcode technology. So the equipment budget was about $40,000. Add on another $10,000 for installation and software and so on, and you're probably up to $50,000. So it became a significant 10-to-1 cost savings over the barcode method. So that was decided. And so the next question was, okay, what kind of data collection system can we deploy that will allow us to efficiently map all these vines at the centimeter level? And so when you look at the criteria, first of all, it must be very fast. The target was about 3 seconds per vine, and it starts to make a big difference. This was a big concern for the Vineyard. If it ended up taking 15 seconds or 20 seconds per vine, it would be a really labor-intensive task and become quite expensive labor-wise if you map that out over 500,000 vines. Secondly, it must be very easy to teach, because there's not a dedicated mapping staff, and so it could be a mixture of farm labor and office labor, whoever was available. And it must be easy to teach either one of these folks, because they had 2 or 3 systems, and so maybe they had access to 12 people at any one time, and so they had to be able to rotate in and out and easily be able to adopt and use the technology. And so you see this picture on the right is an iPhone, and that was the platform they were interested in using was just iPhones because they had them available. They were used to iOS already, so they wanted to be able to use them. And just to give you an idea, on the far right, that's an image of the vineyard with the vine points laid on top, and they're spaced about 3 feet apart, to give you some idea. So if you can imagine 3 seconds to get from one vine to the other, press the button and keep on moving. That was the idea. And then it must be reliable and work all day. This is a bit of a challenge in some scenarios with the iPhones, but we've got an extra battery pack that we include with those. It became a handheld type of ergonomic, and I'll show you an image here in a second. So the third task was, okay, let's say we collect all this data, 500,000 points. How are we going to manage it? Because part of the challenge is that they've actually had the vines mapped before over time, over the last decade, and they mapped it at the sub-meter level, which became a bit confusing because the vines are only separated by 3 feet, and so if you have a sub-meter receiver, you can start to mix vines up fairly easily. But really, the biggest issue with the previous mapping effort was there was no system of record. And what I mean by there's no big bucket that they would put a central bucket that they would load all the data into and manage it in that bucket. It was sort of spread out among different applications on different computers, and then when you tried to combine them all together, they wouldn't line up right. And so the data management part of it really became an important task for the Vineyard, and so it must have spatial integrity, so we be able to deal with different mapping datums, and this system would become the spatial data system of record going into the future. It would be the gold standard. And again, it must be reliable and able to handle 500,000 records of vine data plus all the imagery behind it, future data, for example, inspection data, because it's going to be an ongoing project. This first phase was only just to establish the centimeter position of each vine. There will be an ongoing effort to inspect each vine and update the records in the database. And so this data management system had to be powerful enough to accommodate today's data and the data moving forward. So we went through a pretty exhaustive search to find an optimal data collection and management platform. And what we ended up selecting was the ArcGIS Online platform as the data management platform. It's powerful enough to handle the volume of data we were talking about. It's reliable. It's a hosted service, and so we're not relying on local servers or our own computers. If something happens, it's safe in the cloud. And then also, Esri has a suite of mobile data collection apps, and this actually really became a really important concept for us because, in the beginning, using a product like QuickCapture, which was the initial rollout application, that allowed us to map the vines very efficiently. We ended up hitting that 3 to 5 second target of mapping from vine to vine because QuickCapture is super easy. It's a one button operation. We could train people in really a matter of minutes to be able to use it. But QuickCapture was just the application sort of in task one. If we look down the road with the inspection task, for example, there's no doubt we're going to use the Survey 1, 2, 3 form to be able to walk up to a vine or walk past it because they're so efficient. They're not going to stop and spend 3 minutes at a vine. They're almost never going to stop walking. They'll walk by a vine. If they see a problem, they'll hit a button, noting that, and then and move on. And so Survey 1, 2, 3 is built really well for that. It's got a data collection form and can have many different selections in terms of is it an irrigation problem or a drainage problem or a disease problem or whatever. And then the third application is ArcGIS Collector, which is a really comprehensive mobile mapping software. And we could envision using that to map the irrigation system, the drainage system in the vineyard, the infrastructure. If any of you are farmers or operate agricultural operations, you know how much infrastructure is out there. And so the collector application is really well suited for mapping those kinds of features. So the data from all three of these apps is fed into ArcGIS Online seamlessly. You don't have to do anything different. And they all can run on the same platform. The Vineyard chose to run it on iOS, but you could easily run all three of them on Android too. So that flexibility really made it the ideal choice for this application in terms of data collection and data management. And just to give you some images of what this looked like, there's again on the left, there's the iPad screen. It's got one button to capture the vine location. And actually, we ended up moving that button down to the middle of the screen to make it a little more accessible to people. And so the workflow is that the person would walk up to the vine, steady the antenna over the vine, take a second to do that, hit the capture vine button. It records the position in a second, and then they move on to the next vine. The picture in the middle is the picture of the device. There's an iPhone mounted on this bracket, and you see the EOS GNSS receiver attached to the bottom. And again, this is all giving you survey grade accuracy based on the location of that antenna. Just all you have to do is plummet over the top of that vine within a reasonable tolerance. So you can see the picture on the right, the operator's taking a shot on one of the vines. And again, if we look at the timestamps between vines, we're at about that 3 to 5 second range. And so in terms of data management, once the data is collected, this is what it looks like back in the office. And what's interesting is that the Vineyard could have 2 crews out mapping, and the data manager could be back in the office watching these points populate in real time. And it's really a lot of fun to watch as they move along, and you can see how efficient they are. So I'm going to switch over to a live screen. This is a screenshot here, but I'm going to switch over to a live screen of ArcGIS Online, which is the data management platform. So this is a few blocks of vines in the Vineyard, and I just tapped on the layer to display the vines. And so each one of these points is a vine. And by the way, we're sort of midstream into the project. It started in March, but they did collect 60,000 vines faster than they thought they would, so just under 2 weeks. So I'm going to zoom in and just look briefly at what these look like. So this is one block of vines. And you can see these are spaced out. There's an ID. So the goal here, remember, was really to get a centimeter accurate position for each vine and then have a row number. And if you can see there's a row number attached to each one. But if we just click on that vine, we get specific information about it, which receiver it was collected from, because we didn't want to be confused whether the iPhone was using its own internal GPS or using the survey grade GPS, the EOS GPS. It gives us horizontal accuracy, vertical accuracy, both at a centimeter. And then we have a row number, which is row number 23 for this one, and then a timestamp, and as well as an elevation too. So you could actually make an elevation contour map from this. really just really, in fact, the Vineyard was a bit concerned about the ArcGIS Online platform being too complicated, but they were surprised by the ease of editing data, because invariably you're going to find people make mistakes in the field. They'll do a double tap on a capture vine and have 2 points on top of each other, but they found it's really easy to go into ArcGIS Online and edit that data, either cull it or amend it. And the other thing is its visualization tool. So I'm going to switch to a 3D view of this. So this is all within in ArcGIS Online. You have a 3D scene viewer. This is an oblique view overlaid on a digital elevation map. I'm going to sort of scroll around here and show you how really dynamic this is. It's just amazing how cool this is to sort of visualize the topography and how this fits. There's a lot of elevation change, and I forget, it's probably 300 or 400 feet of elevation change in all the blocks. And this is only one part of the block here. It's kind of neat. If you look at up here in the upper sort of right corner, there's one solo dot up there, and that's actually the base station for the GPS that's broadcasting centimeter corrections down to the users here in the field. But these brown spots are all over here by the base station are also other vine blocks that are going to be mapped eventually. So this is a great visualization tool for managers or project managers to be able to show this to executive management and have them really quickly visualize the value and the effort that's going on here. So I'm going to switch back to PowerPoint presentation. So in summary, we ended up deploying high accuracy EOS Gold GNSS receivers, and they were the most cost-effective method of identifying fixed assets versus the barcodes, right? And whether it's the fixed assets or vines or buildings or irrigation pipe or drainage or utility poles or whatever, the same tool can be used for all those different mapping applications. Secondly, QuickCapture on a smartphone or it could be a tablet is a very fast data collection workflow that can be taught to entry-level labor for large-scale data collection projects like this. And then lastly, the really important piece is the ArcGIS Online component. It's proven to be a powerful and flexible system of record capable of handling large volume of GIS data. Really, that's the ultimate here is you really need a system of record that's going to be permanent. They didn't want to run into the same problem before where data sets ended up on different computers and different software systems. And when you try to combine those, it was just a mess. And so this ends up being a great system of record for them moving forward. Well, thanks for tuning in for my presentation. And any questions, here's my contact info, and stay safe.